Thank you for joining us. I'm Blake. I work with Teleport as a solutions engineer. We provide access to all of your infrastructure anywhere with the zero trust solution. And that's what we're going to be talking about today is zero trust and how we can replace depth with logic, both on a general scale, and we'll take a look at Teleport as well. Now, we're going to be talking about, again, how access is handled today, taking a look at a couple case studies, talk about my own experience having worked in DevOps, and then dive into how things can be solved going forward. Now, as far as how things are handled today in a typical legacy enterprise environment, we're relying on password vaults, shared keys, VPNs, and that typically comes with an ununified auditing and traceability aspect to that. And by that I mean, as you're moving between Kubernetes to SSHing into your Linux environment to accessing your database, being able to maintain a end-to-end trace of what somebody did throughout their work session is something that you typically can't see in any normal access solution. And then different solutions for different platforms is often a big problem, especially when we're looking at multi-cloud environments that everybody's working in today, with whether it's AWS or GCP or Azure, as well as private cloud or self-hosted. Being able to address all of your infrastructure from a single point is definitely key when you're considering how you can unify access in a safe way. So what's wrong with the legacy access solutions? Well, I can tell you just from my own experience. I was DevOps at JPMorgan Chase for several years as an engineer within the hedge fund industry, and then even before that I was at General Growth Properties, a real estate investment trust, and everywhere we were relying on shared passwords. And typically how that would work is I'd have to get a ticket number, go to a password vault, pull out my password, and access my infrastructure. Now, that whole process to get the ticket, to meet all the ticket requirements, to go and get the password and meet the documentation requirements, that would take several minutes, 5-10 minutes sometimes, depending on what kind of ticket I needed to make. So if somebody had already pulled out that password on my team, I might just ping them, ask them for the password, save me time so I can get into the infrastructure and fix the problem sooner, which was an innocent ask, I guess, on my part, but it's an easily exploited loophole that somebody might be building within your just-in-time access solutions. Now, keys are also a commonly targeted vulnerability. Sometimes up to 35% of SSH traffic in the world is actually just scanning for keys. Now, keys are something that you can harden, but again, they are something that once compromised are not easily revoked. Now, maintaining complete traceability is not likely with legacy access solutions, which is something I just covered. But yeah, again, moving between Kubernetes and seeing what somebody's doing in an exec session, and then following them to the next stop, which might be an SSH session to a Linux host, and then to the next stop to a Windows server or a database. Maintaining that end-to-end traceability of what somebody is doing throughout their workday is not easy to accomplish, and that is something that a lot of enterprises, progressive enterprises, are definitely desiring today. Now, typical solutions today are going to lean more on the side of security when you're trying to balance out security and agility. And with that, you're definitely addressing your legal risk, but it's leaving the door open for reputational and financial harm. And that can really kind of metastasize in a number of ways. But if we take a look at Equifax in 2017, definitely some irreparable financial and reputational harm was done here. And this is all done because a admin username and password were being used for a dispute portal Equifax had, and that provided public-facing customer data. And behind that, there's a lack of auditing, session traceability, no multi-factor authentication. I mean, customer names, addresses, social security numbers, a lot of personally identifiable information was compromised. Ultimately, $700 million in fines were leveraged against Equifax, and it was pretty significant. And this worked as a case study to not only update your password beyond default of the admin, but also increase your just complexity in general, implement your multi-factor authentication, find solid, robust auditing tools. But regardless of how strong your password is, a password's always going to be a vulnerability. So if we can just, rather than changing admin to something that's 8 characters with 2 symbols and a capital and a number, what if we could just replace it and nothing could be brute forced, and we had an easily revocable certificate used instead? And we can take a look at that in just a minute. But I also wanted to talk about Colonial Pipeline back last year, 2021. And this was just a compromised password that was found on the dark web, which is very, very common nowadays. And VPN connection that didn't require multi-factor. So after this Russian hacker was able to buy the password, I assume for very cheap, and was able to make connection to the Colonial Pipeline network, there was no additional layer of multi-factor. There was no additional layer of security. So it's kind of, once you got in, you're in. And what did that result in? That resulted in gasoline shortages, surge in prices, 5-day supply chain disruption for Colonial. And that came with a lot of reputational harm, a lot of financial harm, both for Colonial and for the world. But this, again, proved a couple things here. This proved that any password is potentially compromised. They did the best to investigate. They couldn't find the source of the leak. They went back and reviewed his emails and chats, couldn't find any instance of social engineering, and they did determine that his password was plenty complex. So in the end, investigators were not able to find a root cause as to how the exploit of the password happened. So just again, there's just an inherent vulnerability anytime you're going to be using passwords for anything. And just to kind of circle around to current events, I mean, with the Russian hacking, and obviously there's a lot of traffic coming from over there right now as it relates to ransomware. Being able to step up to a zero trust approach to your access, especially as it relates to critical infrastructure, is really key at this point in time. If you aren't protected, you're leaving the door open, which is where Teleport can step in. Now, replacing passwords with short-lived certificates is fantastic, but these certificates, on top of just replacing passwords, are revocable. They are able to be used across multiple protocols. So as it relates to Kubernetes, SSHing into Linux and Windows, Windows Server access, database access, application access, many different AWS integrations. And we remove passwords from all of these different scenarios. And the way Teleport does this is, well, you're going to start over here on the left. And interfacing with Teleport through one of a couple ways. There's TSH, that's our command line utility. There's also going to be a GUI client we're going to take a look at. And then there's Teleport Terminal, and that's going to be a new product that's going to be released relatively soon for more of a unified Kubernetes and database experience. And we'll take a look at that, where that will come in a minute as well. But after you reach out to the Teleport proxy, it's going to reach out to the Teleport authentication service, either authenticating locally or reaching out to your SSO provider. Based on those group claims from your OIDC or SAML provider, one or multiple Teleport roles will be applied. So each role has a time to live. Based on the principle of least privilege, the lowest time to live is going to be applied to the X509 TLS certificate that gets issued. And that certificate can be leveraged for SSHing into your Windows and Linux, your Windows server, Kubernetes, databases, as well as applications and those AWS integrations that I had mentioned. Now, with the certificate, one extra benefit, especially as it relates to traceability, is there's a lot of metadata about the user, and that's going to be that certificate that's going to be leveraged across the entire Teleport session. So again, for that end-to-end traceability and finding out where your user went, it's really unbeatable. Now, as far as just-in-time access, up here we support a few different solutions out of the box, like Slack, Mattermost, Jira, PagerDuty, GitLab, and email. And then it's just very, very customizable beyond that. So with Slack, definitely our more common integration. So I, as a user, have access to request specific roles. You, as a manager, have access to approve requests for specific roles. And if it's ever appropriate, we can require multiple levels of management to approve an access request before that elevation is granted. So I, as a user, can go ahead and generate the request. A notification will get sent off to a Slack channel. I, as a manager, can go ahead and click on it, hop in, and approve. Now, with PagerDuty, it's a little bit more comprehensive, where you can schedule out people's shifts. So as people work on call, as people are working on the weekends, it'll automatically approve the elevated access request, at least whatever level you think is appropriate. Now, at my last workplace, where I would have to go to ServiceNow, create a ServiceNow ticket, go to my password vault, supply the ticket, get the password, and then access my infrastructure. Now, that same kind of workflow can be accomplished here. I did build out that integration where I provided a ServiceNow ticket to Teleport. It goes and checks to make sure it's within SLA, it meets priority requirements, and then it'll automatically approve. And if it doesn't meet requirements, it'll automatically deny, or if it doesn't sense a ticket number, it'll just skip and wait for manual processing. And I'm only saying that just to kind of illustrate how customizable it is, and really show that whatever your access workflow is currently, we were very likely to be able to support it. All right, I'm going to go ahead and log in with Okta. We'll go in as my admin account here. All right, so one thing that's going to be pretty consistent throughout your Teleport experience is this label-based access, and that really helps us break down that access as granularly as possible, especially when we're using the RBAC controls, and we'll take a look at that in a minute. But these labels can be simple, like environment equals prod, or it can be a little bit more dynamic, like host name equals output of the command host name. We also have integrations with AWS that we're able to help you build out, where you can automatically pull in EC2 tags and turn those into labels. So as you onboard your instances, it makes permissioning really, really easy and seamless. Especially when you consider that we also have EC2 auto discovery, again, where you're onboarding EC2 instances and they'll automatically be spun up with Teleport and connected to your cluster. So both things to consider, and we're going to circle back and take a closer look at SSH in a minute. And this is applications. So this is going to be covering a lot of our AWS integrations. So AWS console access and CLI access. And then more on like a base layer, it is just proxying public web traffic to your private instances. Now, for apps like Grafana or any other JSON Web Token enabled app, if there's a like username, so if carlos.admin, for example, exists on both sides, we go ahead and pass that JSON Web Token over to Grafana for seamless login. And now with apps like Jenkins that natively have a reverse tunnel proxy, or other apps with similar integrations, we can support those as well for seamless integration. Now with AWS, what we have here is we've deployed an EC2 instance within my VPC. That EC2 instance has a role that says it can assume a whole suite of roles. Now Teleport takes that access, breaks it down, and federates it across Teleport roles. So from Teleport, I'm able to access AWS console and just assume any of these roles directly through my browser, or I can also do the same from the AWS CLI. So any interaction with like AWS STS API, I'd be able to do through Teleport as well. So let's go ahead and click here. Let's hop right in. And there we are. We're in our AWS access, or AWS console there. Now, as far as user administration, none needs to be done for carlos.admin on the AWS side. That's just all going to be handled through those IAM roles, Teleport, and your SSO provider. Now, if we move on to Kubernetes, like I mentioned, there is Kubernetes and database are both going to be kind of a less unified experience just for this short term right now. We are releasing Teleport Terminal that's coming out, I think, very soon, within the next couple weeks or month. But for right now, within the GUI, you can see what you have access to. It's going to provide us some information on how to log in, and we'll do that in just a minute and take a look at how to access both database and Kubernetes. Now, here's our desktop access. The way that we provide access, passwordless access to Windows servers is going to be with an LDAP-S connection, leveraging a service account and publishing Teleport CA to the NT-auth container. And then we're taking all the user data during login and virtualizing that within a smart card. So when we go in here, all right, so now we're in here as app support. As you see at the top, I have clipboard sharing disabled. That is just to make sure that my user cannot export any data. I've determined that this is going to be a secured terminal. So actually, in this case, I think I have, let's see, MySQL Workbench in here. Actually, one second. Let's hop back out, and we're going to log in as a different user that I think I have set up over here. So let's log in as administrator. All right. So one thing I just wanted to kind of address an additional use case here. So we are logged in. Oops, let's go ahead and close that out. We are logged in as administrator on this Windows host that, again, I've described as a secured terminal. And the reason that we're doing that, well, we've locked down clipboard sharing, so people accessing the database can't export that data because this looks like personally identifiable information that's including dates of birth and what grades and gender people are. So this isn't necessarily information that we would want somebody to be able to export, backup, or copy and paste out of here. So we've disabled clipboard sharing. We do have session recording turned on, and we'll take a look at that as well. And then I also have a, this connection here. Let's see if we go back over here. This connection here, as you can see, is also going through a teleport cluster. This cluster is exposed to my cluster through a, this cluster is exposed to my cluster privately. So I have to access, the only way I'm able to access this database is by logging into this secured server without clipboard sharing and with screen sharing, with session recording enabled. And that really ensures a maximum level of traceability and accountability as your users are accessing the most secure data in your environments. Now, if we keep going on here, we can take a look at our activity here, and we're going to circle back. So we have active sessions, we have session recordings, we have audit logs. We'll take a look at all those in just a minute. And then as far as roles, just to kind of give you an idea, we can hop right in here. Let's go to our access role. So access role is kind of showing you how the label-based access works. So a lot of this is all wildcarded for easy use on my end right now, but we have our app labels, our database labels, names, users, Kubernetes groups, labels, users, SSH logins, and the node labels I've allowed user to have access to as far as SSHing. We do have enhanced recording, which I mentioned earlier, is going to be that kernel level logging. So as far as being able to capture those commands that users are running within their session, have it stored in a JSON format and export it to like Splunk or Datadog or Elasticsearch, and really build out like actionable alerting on that data, you'd be able to do that with enhanced recording. And then down here at the bottom, finally, we have our max session time to live. So that's that time to live that gets applied to my X509 TLS certificate. So let's see, if we hop over here, let me hide this real quick. There we go. All right, we're going to hop back in over here. And we're going to take a look at SSH as well as some of the access controls here. So if we hop in, we're going to hop into a different browser here and log in as a contractor and walk through the whole access control workflow. Okay, cool. So, whoops, I logged in as the wrong user. Okay, so here we are. We're logged in as Joe the contractor. Behind here, I still have Carlos the admin logged in. And we're going to pull up my command line because we're going to do a side-by-side here in just a second. But over here is Joe the contractor. I'm going to go over to my access requests and take a look at these. I'm going to go ahead and just send 2 access requests just to show you the difference in how they might behave. So here we go. I'll send this one that just says test. All right, and then we're going to put in actually a couple here with ticket numbers just to show you how this might work. And then let me grab one other ticket number here. All right, so now as we can see here, we've just sent these all in. If I go ahead and refresh here, we can see that I have this one is approved, this one's denied, and this one's pending. So 8111 is a ticket that does not meet priority requirements, so Teleport automatically denied the ticket. Now, the one ending in 005 does meet SLA and priority requirements for this level of role that was requested. So it went ahead and automatically approved that access request. And then it didn't sense a ticket number in this request reason, so it left it for manual processing. Now over here with our Slack integration, the way that you can kind of see how this would work is you can see how the statuses are updated as they get updated. So you can see what it said here, automatically approved because it meets SLA and priority requirements, and the other one was denied. Now if we go up here, we can see the other one with the reason of test that's still in pending, and it is still pending here. We can hop in as Carlos and go ahead and approve, and again apply justification if we'd like, and go ahead and submit that. Now if we go over here now, we can assume this role, and we get this nice little 8-hour countdown, and this is based on the time to live within the admin role. Now I have the same access as Carlos does. Okay, so now I'm going to go over to the command line, and we're going to do a quick SSH demo now that we have Joe logged in. So TSH status is going to show me who's logged in. So it looks like Carlos is logged in over here. I've got 7 hours, 58 minutes left. So now TSH, SSH, let's hop in as root over on this host. And we're going to start typing a command. So we'll leave our ls there, and we're going to go over here as Joe the contractor. Now as long as Joe, which we know he does, has access to the same user and the same host as Carlos, and he has access to active sessions, we can actually hop right on over here and take a look at what's going on. So if we hop in, join session, we can see this ls that Carlos has left off. So now over here on the right, as Joe the contractor, I can continue to finish the command line, and then Carlos can also just pick up right where Joe's leaving off as well. So it's really nice for onboarding, shadowing, and also in addition, with bringing on maybe like external vendors. If you're bringing in anybody that you don't completely trust or know, and you need to provide them access to your infrastructure, you can actually enforce session moderation with that elevated access request. So as somebody logs into your infrastructure, somebody else's eyes have to be on the glass and watching what's going on. And again, just giving you that extra layer of safety and accountability. But now if we go ahead and exit here, we can go ahead and take a look at how this is all recorded. Now let's see. Let's go to activity, audit log. And what we see here, if we go down a little bit, let's see. We can see Carlos's certificate get issued. So let's start there. This is all that information, that metadata that's tied to Carlos's certificate. All the information that we would need to know, and this is everything that's going to, again, add just an additional layer of traceability as you're moving between your various sessions. But we have that certificate that got issued. We can see when everybody got connected, when Carlos started the session, when Joe joined it. We can see when the session ended, and we see a session uploaded here. These are all logs that are stored in JSON format. So like I was mentioning earlier, if you needed to send this off to maybe like Datadog or Elasticsearch, Splunk, these are logs that you would be able to ship off and build out actionable alerting on or data analytics. Now again, if you turned on enhanced logging, all the commands that I would have ran would have been recorded here as well. But in absence of that, we do have session recordings. So session recordings are going to be, well, we can see Carlos and Joe right here on this host, and we can hop right in. And it's going to be this really nice copy and pastable playback, which I know from my time in DevOps that a lot of my time was spent building out knowledge base articles, run books, documenting major incidents. So rather than relying on screenshots or transcribing, this saves a lot of time to be able to just copy and paste as you need to. Now, if we go back, we're going to take a look at Kubernetes and then database next. So let's hop over here under the command line, and we're going to go TSH kuba ls. And that's my cluster that I have access to. So if we go into TSH kuba login, we'll just hop into that development cluster there. And what that did there was that copied down and merged my kubeconfig locally. Now at this point, if I wanted to go either from kubectl or from Lens, I can hop right in and leverage my TLS certificate in addition to my my local kubeconfig and get working on my working on my clusters. And again, because this is something that is copied down and merged and not replacing your kubeconfig on a day-to-day basis, as an engineer, I'm only going to need to do my SSH login, get my certificate, and as long as I already have that kubeconfig, I can hop right into my pre-existing tools. But at this point, we can hop right in and go kubectl get pods. Whoops, I think we need to put in the namespace. Yep. So, all right, and then we're going to just hop in and do a quick exec here. So kubectl -n. Ooh, couple too many T's there. And then exec IT, and let's hop into this pod here. All right, just running a quick easy command, and we'll go ahead and exit there. And then we'll take a look at how that got recorded as well. So if we go over here, go to our audit logs, we're going to see any interaction with the Kubernetes API is going to be recorded in the audit logs. So right here are our Git pods, the first one without the namespace, the second one with the namespace. Rather than kubectl, it's written as a API response because that's what we're recording is any interaction with the Kubernetes API. So we see Git pods here. And again, this would be something that would be shipped off to your SIEM to build alerts on. And then over here is our exec. So again, just like SSH, we don't see any additional audit logs for what happened in that exec session, but we do have a session recording. So we can see Carlos was on this cluster, execed into this pod, and if we go back and play it, we're going to have that same nice playback that we had for SSH for our Kubernetes exec sessions as well. So again, very, very nice as far as end-to-end traceability and figuring out what happened during any individual session. So now let's hop back over here. We'll take a quick look. Well, actually, I'll just hop into Lens real quick and kind of show you how this is all set up. But as you see here, I have all these different clusters that are all getting proxied through my teleport cluster. If we hop right in, we can take a look at our pods. And again, I just want to show you this just to show you that your pre-existing tools do work. There isn't a ton of information for me to look at here, but you can see that my nodes and my pods are working. Whoops. But yeah, you can see that my nodes are up. You can see a little bit of information about my cluster just based on the little bit that I have set up here in my demo environment. Now let me go ahead and close that. Let's go on to database here. So SSH DB Like I mentioned, database and Kubernetes are going to be more of a unified experience. So that same look and feel that we have for the GUI over here is what Teleport Terminal is going to feel like, except you're just going to be able to access database and Kubernetes from the same pane of glass as all the rest of the features. Now, as far as accessing from the command line, though, we're going to go SSH DB login, DB name, and call it the schema here. All right, so what happened there was we actually copied down and merged a kubeconfig, sorry, still stuck on the last one. We copied down a SSL cert. So with SSH DB config, this is all the information I would need to set up any SSL enabled IDE for MySQL. So in my case, I'm using MySQL Workbench, and that's down here. We can take a look at that in just a minute. But at this point, I can hop in and do SSH DB connect, and we're going to call it the same stuff here. So let's go like that, and we can just run a quick select. So, and let's go ahead and exit there to show you how it gets logged real quick. So if we go over to audit logs, we're going to see Carlos running this select query on that schema on this database. If we open it up, see a little bit more information, I can see the address to my RDS instance, I can see the database user that was used, a little bit more information about who I am, what I did. Again, these are all things that would be shipped out to your SIEM. Now, one other thing to note on database access is just like EC2 auto discovery, for AWS we do have RDS auto discovery as well. So as you're spinning up databases, we can automatically add those to your teleport cluster. So it really makes onboarding easy. I think we covered everything here. So we've covered SSH. We took a look at the auditing. We took a look at the session recordings and how elevated access requests work. And then we took a look at applications, how JSON Web Tokens can get you seamless authentication, how you can use our AWS or Teleport to get you into your AWS environment, both from the console and the command line. We did our Kubernetes access and took a look at how interactions with the API are audited, as well as the exec sessions, and same for database. One thing that I guess we can circle back on real quick is going to be our desktop session recordings. So now if we go down to here, we can. All right, what you're seeing here is our playback, and to limit the storage requirements needed, we're actually just capturing PNGs at every input. So whether it's moving a mouse around, whether it's typing, it's going to capture a single PNG at those different points, and it kind of compiles it all together and gives you kind of a nice, like almost stop motion playback for what happened during that session. So again, making sure that you have an eye on how your data is being handled when somebody is accessing a secured database, or just making sure your Windows servers are secure. This is really going to add that extra layer of traceability and accountability to the environment, as well as eliminating passwords, which is really the key here. Now, I think we've covered everything here. Thank you for your time, your ear. You can reach me for any kind of technical advice on Teleport, or if you just want to get in touch and chat about cybersecurity. I always love to talk. My email address is blake.brown@goteleport.com. There's my LinkedIn address. If you'd like to reach out to us and schedule a demo or talk about sales, you can always reach out to us at sales@goteleport.com. Again, thank you for your time, and I hope I said something of interest to you guys, and have a great day.